Computer images showed the radioactive material was lifted 5,000 meters into the air. It was then carried by westerly winds and spread over the Pacific Ocean. The images indicate that on the fourth day after being vented, the substances reached the west coast of the United States, and on the seventh day, they approached Iceland after crossing the Atlantic.
The scope of Japan's nuclear disaster could change in an instant with a big shift in the winds. CNN meteorologist Chad Myers is keeping tabs on the weather in the disaster zone. Let me just ask you first, Chad, we just heard the president saying that in fact no U.S. territory is in danger, and neither is the U.S. coastline. Is there another place other than Japan that is in danger given the prevailing winds?
Given the prevailing winds now, no, because of the way the winds will disperse the radiation. Plus, by the time it makes landfall anywhere, 3 or 4 days even for Russia, that most of the radiation the isotopes would have degraded to something non-radiational. It would just be things flying around the atmosphere. I want to take you to a couple of things, Candy. We'll step back a little bit. This is a model that will show you where the wind will go. Take you right here to where the wind has been. And in fact, the wind blowing off the country, off the shore of Japan, affected the water drops. I was watching the water drops live here from an NHK feed, and the wind was literally blowing that water that they were trying to put on this little reactor, just blowing it in the wind. And that was the wind that we saw last night, and we still see on this satellite picture now. That wind will change, and it will change from offshore to very close to deep from the south to the north, and that would move this radiation plume. We know there is one, it's just not big enough to make it to the U.S. It could move it up towards Sunday in the next couple of days. The winds will not be offshore anymore by Saturday. They will be pointing at the northern part of the island of Honshu. Now back to this graphic, because there was a lot of cutting and pasting going on today about a graphic that made its way around the internet about how this plume of radiation was going to make its way to California tonight and tomorrow. That was a theoretical model that was put out just for informational purposes about a plume that didn't even exist. And that's what the text said. But if you just cut and pasted the picture, everybody freaked out because it looked like a bunch of radiation was coming to the U.S. today. That didn't happen, and it's not going to happen. Even if some radiation was immediately emitted right now, it would work its way through the Aleutian Islands, back up toward Russia, and then probably up toward the Pacific Northwest. By the time, 5 days later, by the time it would even get close to any U.S. landfall, all the radiation would literally be dispersed. Candy?
So as I understand what you're saying, Chad, the president's perfectly right that there's no reason to believe any U.S. territory, much less the U.S. coastline, is threatened by anything that might come our way. But the city of Sendai, if the winds switch, gets hit with yet another disaster.
No question about that. That is the possibility coming up for Friday and Saturday for that city. 1 million people in that city. I know we talk about how much damage and destruction was done by the tsunami. Not the city of Sendai. Sendai is just fine. 1 million people there, the big skyscrapers there. The coastline to the east of that city, that's what was devastated by the tsunami. The people are still living in Sendai. If the wind shifts and that radiation goes there may be a completely new evacuation plan for that city, or at least an evacuation in place. Stay inside your house, don't go out at all. And that's outside that barrier, outside that window, that radius that they've drawn right now.
Sione, Japanese officials are now talking about fighting 2 partial meltdowns in nuclear reactors. Briefly, what's going on and potentially how dangerous?
This is an unprecedented crisis. It is extremely serious. One of the reactors has had half their core exposed already. This is the one they're now flooding with seawater in a desperate effort to prevent it from a complete meltdown. They also have lost control of a second reactor right next to it that is a partial meltdown, and there actually is a third reactor at a related site about 20 kilometers away that they've also lost control over. So you have multiple reactor crises at the same time. We've never had a situation like this
before. And what does it mean if you have a meltdown of a nuclear core?
The worst case scenario is that the fuel rods fuse together. The temperatures get so hot that they melt together into a radioactive molten mass that bursts through the containment mechanisms and is exposed to the outside. So they spew radioactivity into the ground, into the air, into the water. Some of that radioactivity could carry in the atmosphere to the west coast of the United States.
Really? I mean, thousands of miles across the Pacific.
Oh, absolutely. In Chernobyl, which happened about 25 years ago, the radioactivity spread around the entire northern hemisphere. It depends how many of these cores melt down and how successful they are on containing it once this disaster happens.
Now, you talk about the possibility of a huge exposure. The Japanese officials so far have evacuated people 12 miles from these plants. Is that far enough?
Not under a meltdown scenario, and you've seen these evacuation radiuses extend as the crisis has developed. First it was 2, then it was 6, now it's 12. We're told by some reporters on the ground that actually 50 kilometers out they're being blocked from access. So the effective evacuation area is actually larger than the official one that's been declared.
Put this in context. Japanese officials had been rating this as a 4 on a scale that I didn't even know existed, of 1 to 7 for nuclear events. How does the situation in Japan, as it now stands, compare to 3 Mile Island in this country in 1979 and Chernobyl that you mentioned in Russia in 1986?
If it were to stop right now, 4 might be a fair categorization of this, a local event without significant injury. But if it continues, it will certainly get to 5, which is the 3 Mile Island category of a serious event. We almost lost 3 Mile Island. It almost went meltdown. It stopped at the last minute. That's the situation we're fighting to maintain here in Japan. If there actually is a meltdown, that puts it into a 6, even a 7. That's the Chernobyl category, a serious nuclear incident with potential for large-scale loss of life.
So what are we talking about? 12 hours, 24, 48 hours? And what are the keys as to whether this becomes just a serious accident or a catastrophe?
We're in the key period right now, so the next 12 to 24 hours will tell us whether the Japanese officials are able to get control back over these reactors or it's gone, it's lost.
It starts at the Takasaki radionuclide station, around 200 kilometers away from the troubled plant. Within 4 days, the dispersion of minuscule amounts of radioactive isotopes were detected in eastern Russia and then travelled to the west coast of the United States. Traces from the accident in Fukushima were detectable all across the northern hemisphere, where it remained with the equator initially acting as a dividing line between the northern and southern air masses. But in a little over a month, traces from the release had reached the southern hemisphere.
Plumes from Japan will reach the U.S. West Coast tomorrow, have alarmed many Americans. Chad Myers is with us now. So, Chad, experts are telling us that there is no cause for alarm or panic, right?
Well, yeah, that's correct. And you want to know why?
Tell us why.
Because all of the graphics and all the animations you've been seeing in other places online that show this plume of radiation reaching the West Coast as part of a computer model that was run this week for a plume of radiation that escaped from Japan on Saturday. The only problem is there wasn't a plume. So all of this talk about this plume is coming to the United States is all debunked because there is no plume. There's no radiation in the air.
And it fell upon the third part of the rivers, and upon the fountains of waters. And the name of the star is called Wormwood. And a third part of the waters became wormwood. And many men died of the waters because they were made bitter or poisonous. But I'm telling you, the poison is here. The implications for human health is disastrous. It's way worse than originally thought.
They're literally making it up as they go along. We're in totally uncharted territories. You get any nuclear engineering book, look at the last chapter, and this scenario is not contained in the last chapter of any nuclear engineering textbook on the planet Earth. So they're making it up as they go along, and we are the guinea pigs for this science experiment that's taking place.
Because there is no plume. There's no radiation in the air.